So in this section, we're going to look at the art of measurement. So imagine you're in the lab and you want to measure a volume, and maybe you're going to use something like a measuring cylinder. So a measuring cylinder is made of glass. And the ones we have in the lab are a little bit better than this, but just for illustration, let's go ahead and draw a scale up on the side. So 10, 20, 30, 40 milliliters and so. And we go ahead and we fill it up with water, and maybe we fill it up to water, and the water level looks something like that. And if you notice, the water actually curves up at the edge. That's called a meniscus, this layer, and due to surface tension, it's attracted a little bit more to the glass than it is to itself, so it actually sneaks up there a little bit. When you view it, you have to look at the bottom of the meniscus and kind of read where it is on the scale. And the rule of thumb for making any kind of measurement is you always measure and you read to 1/10 of a scale division. So if these divisions are 10 milliliters apart, you would estimate to 1/10 of that. So if it's 10 apart, 1/10 of it would be to the nearest milliliter. And if we look at this and we just try and ask ourselves, how many tenths of the way up it is, maybe we look at it and we say, well, maybe it's 4/10 of the way or 5/10 of the way. I'm not really quite sure. So maybe if I think it's 4/10 of the way up, it would be 24 milliliters, and I'm absolutely certain about this. I know it's 20 something, but this last digit here I'm a little bit unsure about. I'm a little bit uncertain about. In fact, when we make the measurement, we normally sort of agree that that last digit there that we're not sure about could be one bigger or one smaller, or maybe we're lucky and it's exactly on the money. So when we write 24 like that, we're really saying it's somewhere between 23 and 25, and 24 is the most likely position. And of course, if we have a more finely divided scale, we can try and estimate it even better. So let me go to a new slide. And maybe we have another measuring cylinder and it's calibrated a little bit better. And as we zoom in, maybe this is the 23 and this is the 24 and this is the 25 mil mark on. And if we look at our liquid, it is, oh golly gosh, maybe it's something like that. And again, we got that curvature at the bottom, right? That meniscus, that skin there, it sort of creeps up at the edge. But we really want to focus on the flat part of the bottom there. And we go ahead and we try and estimate it to 1/10 of a division. Now, a division now is 1 milliliter apart. And we're going to go ahead and say this is maybe 3/10 of the way between 24 and 25. So it's 24 and 3/10, so 24.3 milliliters. And again, we are absolutely certain about the 24. It's 24 point something, but we're not quite sure. That last digit there is uncertain. It is plus or minus 1, which is to say, when we write 24.3 in chemistry, we don't actually mean 24.3 exactly. We mean it's somewhere between 24.2 and 24.4. So we've got this uncertainty here. Now, we would say this measurement has 3 significant figures. So I'm going to write this out in full, which is probably going to be one of the last times I'm going to write significant, I can't spell, figures out in full, because we normally abbreviate it either as 3 sig figs, which when we say it out loud is normally how we'll say it. When we write it on the page, though, we'll write just SF for significant figures. So we would say it has 3 significant figures, or 3 SF. And the rule of thumb is that the number of significant figures is the number of certain digits plus 1. So it's the number of digits, if we like, that we are absolutely certain about. So in this case, it would be the 24, and plus the one extra one that we've read that we're unsure about. And again, you might say, well, if we're unsure about it, why should we write it down? Well, it actually does help us, because although we don't know for sure it's 0.3, when we write it like that, we're saying it's close to 0.3. So it's between 0.2 and 0.4. And it would be silly to throw that away, because 24 could mean anywhere between 23 and 25. 24.3 means it's anywhere between 24.2 and 24.4. So it gives us a little better idea as to how much liquid is really in here.